Everyone is just scared of numericals in your class 10th. But nobody is actually talking about the solution. The solution is making a formula sheet, writing all the formulas down that exist in your complete class 10th physics, and then try to understand them and mug them later, because that is also important if you want to remember the formula in your boards. Right now, this video is better exactly for this. I will tell you all the formulas that you need to learn in your class 10th in just this particular video. Now, talking about all these formulas, let's quickly start with the very first, our very important and very difficult chapter, it seems, to the students, the chapter light, reflection and refraction. Now, the reflection part we have mirror, the refraction part we have lens. If you want, you can just take the screenshot, or I will suggest that making this formula sheet as I go through this whole video, just take a random paper, write everything down, and that's it. No need to go through all the book, all through NCERT. Just revise these formulas in this video and you'll be sorted. Okay. Also, for you, I will give the PDF in the description as well, with all the formulas written exactly like this. Now, for mirror beta, the formula, the mirror formula, what is it? 1 by f equals to 1 by v plus 1 by u, where u is what? Object distance, v is what? Image distance, and f is our focal length. For lengths, same, but 1 by v minus 1 by u here, right? 1 by v minus 1 by u, that's the main difference. Talking about magnification, it is minus v by u in case of mirrors, negative sign v by u, image distance by object distance, also equals to height of image by height of object, basic. In the lens, this is plus. Make sure this is important. It is m equals to plus v by u. Write down as I speak. Okay, then beta, we have the formula for power. 1 by focal length if focal length is in meters, 100 by focal length if focal length is in centimeters. Done. You will get the PDF in the description, don't worry, but write it down as well. Okay, then last, refractive index, big formula, but only one formula you have to remember, everything will be sorted. N21 equals to, that is refractive index of medium 2 with respect to refractive index of medium 1. That means refractive index of medium 2 in the numerator divided by refractive index in the your medium 1. The V1 and V2 are inversely proportional to N1 and N2. So N2 by N1 will be V1 by V2 equals to sin I by sin R. That is your second law of refraction. Done. Next beta, the second slide, it is very important. We know mirror and lenses. When we talk about mirror and lenses, that's the one thing we miss, that is the sign conventions. So the first thing, what is the focal length of concave or convex, mirror or lens? So for everything, whatever it is, if it's a lens, if it's a mirror, if it's concave, then the focal length is negative. Concave, focal length is negative, beta lens, beta mirror. If for convex, a mirror or a lens, for both, focal length will be positive, focal length will be positive. Oh, I wrote negative here. Yes, it will be positive. How do you remember this? When this x comes, if I rotate this x, it will look like a plus. So focal length is positive. Okay, that's how you remember the focal length of convex. And then concave is obviously negative, right? Now beta, we talk about all the cases. Concave mirror has 6 cases. 5 are pretty normal. 6th one is a stupid case. Now in the first 5 cases, we get a real and inverted image. We all know that. Now following that, the sign convention, u is always negative, object distance is always negative. We know that image distance is always negative in case of real and inverted. In case of mirror, remember this, it is negative for a mirror in case of real and inverted. Okay, and then magnification is negative. So when everything is negative, m is negative, u is negative, v is negative, even focal length is negative, you have concave mirror. Done. Done. Coming to virtual and direct, u is always negative. We all know that. But if v is positive, magnification is also positive, focal length is also positive. No, focal length is not positive. Here, the 6th case, virtual and direct, for concave mirror, v is positive, u is negative, magnification is positive, focal length is negative. It's a concave mirror. Coming to convex mirror, now convex mirror has positive focal length. It has only 2 cases. What are those 2 cases? Always the image is virtual and direct. Always the image will be diminished. The image will always be diminished, right? But u is always negative. V is positive for virtual and direct. V is positive for mirror, and magnification is positive as well for convex mirror. These are the all things you have to remember. Then coming to lenses. Now concave lens similar to convex mirror, just two cases. What are those two cases? Virtual and erect. U is always negative. But in this case, V is different than mirror. In lenses, in mirror, if the image is virtual and erect, V will be positive. But in lenses, if the image is virtual and erect, V will be negative. That's the one difference you have to remember. Coming to convex cases, again it has 5 cases as real and inverted. These are the first 5 cases. The 6th case is what? 6th case is virtual and erect. It is U is always negative. V. Now in case of lenses, if we have virtual and erect image, it will be negative. Then magnification beta will be what? It will be positive. Done? Magnification will be positive. Why? Because the image is virtual and erect. Now see one thing. Virtual and erect, magnification positive. Real and inverted, magnification negative. Virtual and erect, magnification positive. Virtual and erect, magnification positive. Virtual and erect, magnification positive. Real and inverted, magnification is negative. So magnification is sorted. U is always negative. It's just the V. It's only the V you have to remember. Magnification, real and inverted negative, virtual and direct positive. Done. Anywhere, done. Or any case in mirror, in lenses. U is always negative. Talking about V, that's the only thing you have to remember as we make the cases. For concave mirror, if the image is left hand side, then it will be negative. But that's the same. Concave, the axes are the same. In lenses also, if the image is left hand side, it will be negative. But in this case, in mirrors, real and inverted will be left hand side. In lenses, real and inverted will be right hand side. That's why V is positive here. That's the only difference you have to remember. In mirrors, real and inverted will be negative image distance. In lenses, real and inverted will be positive image distance. Write it down. This is the whole chart. You can take a screenshot. Let me get out of the frame. Okay. Then moving on to the chapter beta human eye. All that was the chapter light. Moving on to human eye, we just have two things to remember. The formula is same. 1 by F equals to 1 by V minus 1 by U. We are using lenses here, right? There is a video uploaded as well for all the one shot of human eye as well as all the numericals, assertion reason, MCQs as well, and I'm coming live as well. So you can join all those sessions. Now, in human eye, you just have to remember these two, hypermetropia and myopia. To correct hypermetropia, we use convex lens. To correct myopia, we use concave lens. To correct myopia, we use concave lens. To correct hypermetropia, we use convex lens. Convex lens has positive focal length, concave has negative focal length. This is a lens. Remember, we don't use mirrors in human eye. Okay. Now, hypermetropia is called far-sightedness because we cannot see far. We can see far objects clearly, but not the near ones. Myopia is called near-sightedness because I can see nearby objects clearly, but not the far ones. That's the only formula you have to remember in hypermetropia, myopia in the human eye. Talking about the chapter electricity, we have some formulas. Starting with the very basic, Q equals to IT. Charge equals to current into time. The unit of Q, is what? Coulomb. The unit of Q is Coulomb. Then V equals to IR, our very own Ohm's law due to Ohm Babaji. So what is the unit? Unit of V is, voltage is volt, right? This is what? Potential difference. Potential difference unit is volt. I, again, current unit is ampere. R is your resistance, its unit is ohm. V equals to IR. Then beta, we have one more formula. V equals to work done upon charge, or work done equals to V into Q, potential difference into charge, right? Very important formula. Again, what is the unit of potential difference? Volt. What is the unit of work done? That is joule. Unit of work done? Joule. Q, Coulomb. Q, Coulomb, just like the first one. Then we come on to power. What is the unit of power? Watt. And as we say, हम watt लगा देंगे physics की, right? So the unit of power is watt. The unit of work done, this is the work done, is joule, and the power time is second. So 1 watt equals to 1 joule divided by 1 second as well. Okay, so power is work done upon time, energy is power into time. So energy unit is also joule. The power unit is what? Again watt, time is second. One more formula, two more formulas you have to remember are very basic. In series, if you combine the resistances, that will add up. So R equivalent will be R1 plus R2 plus R3 and so on. And in parallel, they will we will take the LCM. So 1 by R equivalent, remember this is very important. Students do what? They do this calculation and they write it as R equivalent. No, that is wrong. Okay, this should be 1 by R equivalent equals to 1 by R1, 1 by R2 plus 1 by R3. You'll get an answer, you invert it, and that will be your R equivalent. Okay, that's it. The last chapter, if you have reached there by now, will be your magnetic effects of electric current. Just two very simple formulas: QVB sine theta, ILB sine theta. Other than that, these are also then used for conceptual questions. Not the numericals will not be more there. Conceptual numericals only will be there. Okay, so these are the most important things, beta. These are all the important formulas that you need in your class 10th to ace your physics in your class 10th boards. And that is it for this video. Make sure, if I have forgotten some formula, make sure to write down in the description and let me know if you have any doubt. Now, before you leave, a very important thing there is, we have launched a very important course for class 10th, and that is your that the link is available in the description. Go check that link out. You will get top classes, live classes, right? Then you will get consistently weekly assignments, 40 plus part and full length tests. Nobody is giving that. And then unlimited access to post class replays. And what is the price, you will ask? It's beta literally zero. Your seniors has gotten such a good result. They got such a good result, so that we decided to give this course for free to all of you guys. So go check the link out in the description and enroll in that course, so that you can get the assignments and the papers regularly and start your preparation right now. Class 9 is also available, so if you know someone, you can tell them as well. That is it for this video. I'll meet you in the next one. Tada, bye bye.